Hey everybody, this is Larry. This is me going with Cube 4 of the weekly contest for 12 count almost equal pairs too. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This one I actually end up taking an hour on. Honestly, it is a hard problem, but it's not super hard. I think I just messed up on the analyzation. As a little bit of a retro, I thought that I needed to do some inclusion exclusion on this problem on trying to figure it out. But actually, honestly, it was much simpler than that. And knowing what I do know now, it should have been much faster. First thing is, and I also made a very incorrect assumption about swaps and stuff, because we can do two swaps, but those two swaps does not generalize in a good way that I thought that I could have, because I thought that, like, if you have two swaps, then if three things are out of place, you could always change them, which I think is true. But then there's a case where I forgot about the case where you make two swaps on 4 digits, like 2 on 2, and that doesn't make sense for the modeling that I was trying to build anyway. So I was just like really off, and I think I've spent a ridiculous amount of time on it. Like maybe like 30 or 40 or even maybe an hour on the wrong idea. And then after I realized that you could do the 2-2 swap, that I was like, oh, well, what does that look like? And then I kind of just did some work, right? Some math, and without much spoiler, the idea here, the key thing to note is that I would also say 5,000 is a crappy limit, but that's it's a very confusing limit, because I feel like in some languages you could do an n square thing. But in any case, the bigger, more interesting limit is that upper bound is 10 to the 7. That means that every number has at most 7 digits. And what does that mean, right? Well, that means that it's just about brute force if you do the math, able to do the math, because with the 7 digits, then now you can do, in the worst case, you have 7. If you can just enumerate all the cases, right? So then you have 7 digits. Let's say 7 digits unchanged, right? No change. So no, 0 operations, right? So that's one case. So there's one case of this, right? Pretty straightforward, right? Hopefully we kind of and then 7 digits, we have 2 changes, right? Or one swap, one operation, right? And yeah, and then now there are 7 choose 2 cases, right? Which is going to be what is that, 35 or something? 21? Okay, I suck at math. 21 cases, right? And then 7 digits. So what I call 3 changes, 2 swap. I mean, this part's gonna be 7 choose 3, but I'll go over what I mean in a sec. 7 choose 3 is 35, I think. Verifying. Yep. Okay. And what I mean by this is that, you know, you have we swap I and J, and then some J and K. So a more visual example is, you know, you have 1, 2, 3. You want to change it to 3, 1, 2, right? So then here you swapped the 1 and the 2 to get the 1 in the right place, and you swap the 2 and the 3, right, to get it. So then here, yeah, they'll actually, I think technically there are also technically 2 more cases, right? But it just depends. Maybe, I don't know if you want to count them as cases separately, but these are the ideas, right? Because maybe they're just sub cases. Because maybe you want to swap them the other way, meaning that from 1, 2, 3. So here you have this, right? 1, 2, 3 to 2, 3, 1, right? So then here you would instead now you know, you would swap I and J and then I and K or something like this in some order, right? So yeah, so those are technically 2 cases given the same I, J, and K, but But it's just these are sub cases, so maybe we'll think of it that way instead. And maybe not. Let's just write times 2 sub case each, right? Maybe that's better, because now that I think about it, it doesn't make sense. But this is us trying to analyze the boot cases, right? And also 7 choose 2, it doesn't. You have I and J, you just swap them. As long as the chooses should already get rid of the I is less than J part, so you don't duplicate or double count anything, right? And then 7 changes is still going to be 2 swaps, right? 2 swaps, and this is a more obvious, like 1 2 3 4 to 2 1 4 3, where you just swap the first 2 and the last 2, right? So very generously 4 cases, right? And then now, given those 4, you have some, like, it's not quite 4 factorial, but you can think of it as 4 factorial, and it's fine. Well, it's technically 4 choose 2, right? The 4 choose 2 different partitions, but then you overcount them, kind of. But that's fine. If you overcount, or if you have a way to make sure you don't overcount, it's fine. We just want to make sure that we get all the cases, and that all the cases are fast enough, right? If it's fast enough, you can overcount and then do math to remove that overcount, right? Is what I'm trying to say. Okay, 7 choose 4. I don't know what that is. Also 35 cases times 4 choose 2 sub cases each, right? Yeah. Okay, 6, right? Yeah. So this is like swap I and J, J and K. Oh, sorry, K and L, I suppose. This one's a little bit trickier because to handle dupes, we'll talk about why in a second. But as we said, so what is the sum of this, right? It's just 1 plus 21 plus 35 times 2 plus 35 times 6, which is equal to, I don't know, 267, right? So that means that for each number, for each number of 7 digits, we do 267 cases times, let's just say there's an O of 7 for each case to do a lookup or something. So then, that's going to be, like, I don't know, 1500? No. Well, I mean, yeah, it's more than that, but yeah, so let's just say it's 2000, right? All right, let's just times it out. So, let's say it's roughly here, which is, let's just say it's 2000 operations per number, right? We have 5000 numbers, so this looks to be good enough, right? That's basically how I would that's how I would think about it. Maybe. But yeah. Oh, and also I lied, right? No, this is fine. It's 7 digits, is true. For a second, I'm confused. Sorry, this is like 4 a.m. right now, so I'm just like very tired. But yeah, so that's basically the idea, is just to do brute force and have lookup tables, right? And that's, so kind of phrased that way, it makes me a little bit sad to kind of spend so much time on it. But let's go over it. So first, we do a sort, but we don't need a sort. We just kind of sort because we can, so that we can get the digits in a very easy way. And then now, after that, we can move this down. After that, we just do this adding prefix 0 thing. Again, you can maybe just, and that would be fine too. Double checking. Right? takes a while. Okay, there you go. So yeah, so this is just making sure that we have prefix zeros. And then I set up something called P array. It's just I for I in the digits. The reason is so that we can use permutation in it later, so you'll see. But yeah, but honestly, everything is just brute force at this point, right? So here I have, yeah, so I have P choose 4. This is what the combination is doing. So for, I guess I could have done permutations now that I think about it. All right, let's go over this, and then maybe I'll upsolve it with use permutations afterwards, because then maybe that would have been a cleverer way. I was very sloppy on this one. Yeah, maybe. Well, it's permutate on the 2. Anyway, yeah. Anyway, we'll upsolve it in a little bit. So I got a little distracted. But it's just that, okay, we take for every combination of 4. And of course, in Python, this is cleaner. I also, if you watch the live portion, I actually spent a good amount of time writing this recursively, like writing my own thing. And I'm like, oh, wait, Python has magic for this. So then it allowed me to kind of debug this much faster, though it still took me a while, as you saw. But yeah, for each combination of 4, we take I and J, and then we take KL from the remaining things. We created a list from it, though I don't think we needed to do it here, but it makes these things easier. The reason why I have this is just so that I think we don't need it if you kind of check double counting, but it's just for double counting, right? Because if 2 digits are the same and you swap them, that means that we're going to double count later in the 2 case, right? Because that just equals to 1 swap and you don't overcount. But yeah, and same here, and then we just actually do the swaps, right? And here we create a new string from the swap digits, and then we just check to see if it's in lookup, and that we haven't seen before. The scene before, so that we don't do duplicate things, because there may be multiple ways to swap to get the same number, and we don't want to count that multiple times. So like if you do, same swap twice or something, right? And then yeah, and you just count them together and you add it to scene so we don't do it again later. Yeah, that's pretty much for 4. Pretty straightforward, right? For 3, it is the same idea, right? So for 3, we put every combination, we do a swap, we do some if statements to make sure that they're not all the numbers are not equal, so we don't double count, because once we double count, then it also double counts on the P is equal to 2, pretty much, right? And yeah, and then we just kind of create a new string, we add up the lookup, and then we also do another case where we swap the other way, right? As we said, the 2 differences is going from 1 2 3 to 3 2 3 1 2 or 2 3 1, right? I don't know which one is which, to be honest, but if you get them both, obviously it's going to be fine. But you can just you could trace through it. It's not that hard. I don't know. It's fine, right? But yeah, you just do the manual swaps here and here, create a back to string, and then check in the lookup table, and then yeah, and then the last is just 1 swap, right? 1 swap. We already talked about this. We just do 1 swap. It's pretty straightforward. Also, make sure that this is a swap, and then yeah, and then we're Gucci. And then at the very end, don't forget this one, which is 0 swaps, right? Which is just the same identical input of total we added to x. And then we increment it to show that so that the future can look up to here. And that's pretty much it. We already kind of touched about the complexity. It's going to be, 7 choose, like D choose 4, like the complexity is roughly speaking over n times D choose 4, right? Of course, D choose 4 is, I don't know if you want to say it's a constant, but yeah, I don't know. Either way, d choose 4 is technically d choose 4 over 4 choose 2, which makes it, I think, I don't know, but that's basically the idea. I was gonna say, like, you could keep on updating the constant, but I think it's just like something like this, right? And then times d, if you want to say, because you know we are creating a new list to do the swaps, so that's gonna be O of d each, and also both the lookups will be O of d each anyway. So this is roughly speaking the complexity, and O of n space. Right, or O of n times d space, if you want to say that you have n numbers of d digits. Depending on how you want to define n as the input size, right? But yeah, let's see if I could rewrite this a little bit. Maybe I could run this as for every combination permutation of t, maybe. No, I mean, I guess it's the same thing. Because then now you just have different loops anyway. I mean, the reason why I wanted to write a combination is so that we don't double count, but it's still kind of double count, so you still need this thing. The other way would have been faster, but I don't know. But yeah. Yeah, that's all I have for this one though. Let me know what you think. I'll show you the code. Hang on. Yeah, and I did kind of forget the n log n sorting. You actually don't need this, so you can just like, you know, do something like this. Yeah. So you don't need n log n sorting. But so yeah, so then now we have this thing. But I almost never care about n log n, at least for sorting, right? So yeah, so then here again, so this is my code for choosing four things, 2 swaps, right? 4 things changed from 2 swaps. 3 things change from 2 swaps. 2 things change from 1 swap, and 0 swaps, right? So yeah, so here's my 3, right? And keeping in mind that you have to keep track of both of these things. So that's why we have times 2, if you will. And then yeah, 1 swap, and yeah. And 0 swap is hopefully pretty straightforward. I'm not gonna lie, I'm a little tired, so let me know what you think. Let me know if you have questions. Thanks for watching. You can watch me solve it live next. And yeah, thank you. I'm gonna skip ahead for a sec. Also 402, so I don't know. Alright, I mean, maybe give this a try first. The number of operations is twice. Oh, so you can swap 2 numbers. What does swapping 2 numbers mean here? 5,000 is a crappy n, because I feel like in some language n square is fast enough, but in Python it might not be, and I'm not even, and you might have to mind read a little bit whether n square is fast enough, which is kind of crappy. Like, this should never happen for an input, because we just don't know if it's going to be fast enough. Can I do n log n or anything? Do I have any ideas? If I do the delta way, the same as Q1. The number of changes is 3, because it's basically we have 1, 2, 3, and you have whatever 3, 2, 1. Then, but is that too slow? Ten to the 7. What's 10 to the 7? Ten to the 7 is so less than 10 to the 7. So 7 digits. 2 to the 7 is what? 128. 120 times 5,000 should be okay. Is it though? Or how are you doing it, Larry? And not double counting it? Yeah, that's the trouble, isn't it? It's easier to double count. Also, and then you times it by another 7. Yeah, that should be okay actually, but maybe. Let's... Then it becomes n squared. Okay, do inclusion exclusion. Is it inclusion exclusion? Yeah, man. Yeah, today's not an easy day, is it? At least it's nice knowing that I'll be 23rd. Oh, I could have been. Oh, maybe I'll give Q3 a try. I feel like I have Q4 though. Inclusion, exclusion, 7. No, because you cannot have only one item out of place. So you minus the thing that are exact. Is that how that works, Larry? They're exactly the same. I don't know. Can I get the math work on exclusion, inclusion? Okay, so do a lookup on that. It's not 2 to the 7, Larry. It is 7 choose 3. But that's not correct, is it? If they're both precisely the same. Then you would have all 7 choose 2 possible. No, because then you have 7 choose 3 things as well. So it's going to be choose 3 minus 7 choose 2 plus 7 choose 1. What is 7 choose 3? 35 minus 7 choose 2, so that's 14 plus that's 21. That's 20. That doesn't make sense. How am I not doing the double counting here? How do I not double count? Pen and paper time, I guess. Alright, so let's do exactly the same. Then now you would create so in this case it's 4 choose 3, which is equal to 4. 4 choose 2, which is equal to, what is that, 12, 24, over 4 is 6. They all match. And then 4 choose 1 is equal to 4, and 4 choose 0 is equal to 1. So then now, but there's a lot of double counting here. How am I taking out the double counting? So 7 choose 3. Okay, so it's going to be 35. And then for each, so I cannot do the easy math part. So it's 35. And then it's going to be 3 choose 2. Which is 3. Then 2 choose 1, which is 2. So then that's just about like 200 operations. Does that make sense though? Usually I keep on refreshing to see like how many more people solve it, but apparently here might not be sufficient. 51st, wow, people are getting it though. Okay. If n squared works, I'll be very sad also, by the way. But I don't know. No, counter. Right. Digits, max digits. So whatever, just sort. So then digits is equal to something like that. Right. Yeah, it's fine. Okay, so it does what I think it should do. That's not enough. Okay. Do I need index? I don't need index. I don't even know if I'm doing the right thing, honestly. I think this might be wrong for 2 digits as well, because yeah. Have to fix this bit. Okay, let's at least get this right first. Okay. I think I could do combinations somewhere. Yeah, why am I writing this? So we have to index these in a way. I need to rewrite this, but okay. We don't need any of these. I could rewrite this part too, actually. So then now we have tuples. let's just write it. It's not done yet, but I don't want to keep going without more progress, so let's take a look. Also, I'm not doing enough. I need to, okay. Non-local. Minus 90 is probably pretty bad. Okay. So 3. Why is that 1? Why is that 1? Oh, whoops. I guess that's fair, but still not right though. But I should. Shouldn't matter actually. It should be 0 to begin with. I mean, here it's different, but. Oh, I'm printing it after the lookup, so I guess that's fine. Yeah, I'm printing after the increment, so that's why. Okay, fine. That's silly. Okay. But we're not. Okay, so I can't do it quite like this, because then it counts itself. Let's rewrite this real quick. How much time do I even have? 53 minutes. If I'm right, then at least we should be good, maybe. I don't know if I'm getting this though, honestly. Okay, that's what I want, kind of. That's better. That's good, kind of. Okay. This is what we want. Okay. Is this right? I don't know. Is this even fast enough? Also don't know, honestly. This also double counts on this part. Well, that is all zeros. Maybe I've done a lot of nothing. This should be 1. Oh, because we don't, I did not increment afterwards. Okay, that's fair. So I do add stuff, but then I subtract them out. Because of double counting, maybe? So this is 1, this is 2, okay. And then we subtract out these 2. I don't know. Alright, let's just finish writing. Just going to choose 1 by going. Ready? I thought we would have done something. Honestly, a little bit tired. And maybe the server's having issue, maybe my internet is having issue. No, my internet seems fine. I clicked on the one code button, it doesn't do anything, which is not good. Server issues even on a virtual contest. Great. There you go. Okay. Okay, we add this. I thought this would be a general idea, but somehow it is all zeroing out. Okay, it seems to be generating the right things. This should be incrementing. Where's this going? Oh, it's doing all the adding and then it's incrementing. No, that's fine. That's right. That's awkward. That is incrementing the same thing multiple times. Actually. I'm not doing this right. How am I doing it? Okay. I'm doing this incorrectly. One doesn't make sense. What am I doing? So why is how do we never add back one things, even if it's wrong? I mean, I'm doing it wrong anyway. What am I doing? And now server's having issues. I can't. Even doing a virtual, we have server issues. Can't even unload, refresh this. But alright, let me think about this problem while it is trying to refresh. I can't even load this. That's it. No, it's not 4 choose 2, it's 3 choose 2. 3 choose 2 is just 3. Incrementing is not the same though, Larry. I think that's the difference. This is so annoying. LeetCode, why don't you just work for once? Even on a virtual, I cannot get a break on running this code. Is it just me? No, Reddit works. Google works. So it's just LeetCode, right? Okay, it's back maybe. Maybe I'm doing it wrong. Okay, let's try this. Right? 4. I don't think this is right, but just want to see if I get anything, honestly. Maybe I shouldn't have deleted so much code, at least like save it out somewhere. But why is it 0 though? T income. This is if does this code work? This code seems to work. Well, not really, actually. Okay. Oh, right. It's not. This is actually. Okay. So we're 5 and 6. At least it's something. I don't think this is, I mean, this cannot be right because this is not how inclusion exclusion works. But at least with something. Okay. If oh yeah, okay. That's not good enough. 0, 1, 2, 3. Why is that? That doesn't make sense. 1, 2. A lot of, oh, I'm dumb. Larry, what are you doing? Okay. How do I get 4 from this though? This doesn't seem right. Because the answer is 4, the second is 3. There's no inclusion exclusion that makes sense. Right? What does this 2 mean? What am I pointing out? Counts up carry. So that means that the only one that exists is this one. No, that's the other one. Okay, that means that this one. But we double count it, right? Don't we double count it? How do we subtract out the double counting? It could be inclusion exclusion, but this is a mess. Maybe I should have gone for the other one. How much time do I have left? 32 minutes. I don't even know if I'm gonna get a third problem. Double counting. Because basically if you add the last one is 3. Also, I'm wrong. Wow, I miss, because you can do you could do two different swaps on 2 different numbers, so you have 4 things that are different. That's even more wrong. Huh. Whoops. Well, the way that I did it is not that hard to fix, but still. If this would have been right. Wait, is that true? That cannot be true for the first one, because then now maybe I'm just thinking about this all wrong, because it's not swaps if 4 of them are like 1 2 3 4 4 3 2 1. Because if you have 4 numbers, I think it's just brute force lookup, right? Maybe I'm just being dumb. It's just lookup on the brute force, so then you swap. So it's 7 times 7. What is 7 times 7 to the 4? It's still like almost 5,000 though. That is such a silly thing. Yeah, I've been thinking about this all along, honestly. Choose 4 is 35, and then times 4 factorial, 840. 7 choose 4 times 4 factorial. No, you don't even need, is it 4 factorial? No, 7 choose 4 times 4 times 3. So it's 35 times 4 times 3 for the brute force. Okay, I think I know how to do this one, maybe. I don't even know if it's right though, but okay. That's a lot of exploration. Okay, fine. So then now we take 4 digits. So just brute force kind of thing, right? Or like case analysis. Good amount of people's got it. Okay, so then we take 4 digits, then now So we want to swap I and J, and then we want to swap the other two. How do I get the other two easily? This is so dumb. Okay, and then now we have 3 things. Let's do the 2 things first, because I think really? Oh, I don't increment. What? Oh. 9 and 12 is pretty high, actually. Why? So we're still double counting, aren't we? Possibly. I mean, it may be, I don't know if we're doing it here, but definitely still possibly doing it. Yeah, we're definitely up double counting, so this is the double swap, right? Maybe this is wrong. I hope this is wrong. Only because otherwise. 0231, okay. This is probably right. Two, 3, 1, 0. Huh? Oh, because we look up. Oh, I am dumb. Dumbo. Okay, 3, 3. Okay, that's fine because we didn't do the swap 3. Yeah, we didn't do the swap 3, so we should be good. Maybe. I can't believe. How does it do? How would I do it? Swap IJ. And then JK. Then that just becomes 2, right? So we need IJ. So okay, so we have 1, 2, 3. We 1, 3, 1, 2. Then we do. Right? Is this right? I'm so worried about double counting. Is that enough though? I think there's another one where you go the other way. Are we double counting? It doesn't look like we're double counting, which is good. 5 and 6. Well, then because we are double counting. Okay, so this double counts. Is it on the... Oh. Okay, that's good. Maybe. Well, here the 3s are not good either though. Oh, because of the duplicate digits. Five still, really? Four is good. So this is matching. Well, 3 and 2. Why not? Why? How did we add? Oh no. Oh, because I don't add scene. That's okay. That's okay. That's okay. Okay. I mean, is it fast enough? I don't know, to be honest. But the math should be better. But at this point, got a YOLO. How much time do I have left? 15 minutes. Maybe it times out. Ooh, wrong answer is worse than timing out. But how do we... Oh. Huh. Because it doesn't have enough digits. No, that doesn't make sense. Okay, so it does something. Oh, I didn't do the exact thing. Okay, this is easy to fix. Is it 48? Okay, I get 48. I just forgot to do the exact thing. Okay, okay. Maybe we're still Gucci. Maybe we'll just get 5 wrong answers, which is still better than no right answers. Okay, we're over counting because we also do the swap here. Okay, that's fine. I think we just need to do I should have done it this way actually to begin with. Okay. I'm a little bit YOLOing because we have 12 minutes left. I don't have time to kind of think of the wrong answer cases. I'm still overcounting, huh? Undercounting I could make... No, I guess there's no way for me to undercount, but how do I get overcount? And this is now getting a little bit tougher to debug. X is with the prefix. They're the same, then we don't change anything, so we don't count. Okay. Am I missing a thing here? I'm overcounting though. And this part should be the same. Where am I overcounting though? I don't have enough time to debug this. This is a disaster. I should use a permutation here, honestly, but because I think that simplifies my code a bit. know what's the wrong one though. It's so. I can't believe I forgot the zero case, but that's 10 minutes. I guess maybe this is it. All the other ones are right. What am I missing? Are these? Oh, how did I miss this? In that one place. Oh man, I was actually debating whether that's needed, but hopefully, I don't know why that would be needed though. All right, no time to, well, no time to do this problem anyway. But at least we got Q4. But I also just kind of went the wrong approach on Q4 for too much. I was thinking of inclusion exclusion until I finally did the math correctly. And also the other thing was that I didn't use the libraries enough. I think once I did that, that would have been good. But I also missed, and there were just a few minor things like copy and paste here. I missed the not seen part here. And I think the scene thing is not needed except for in the 3 case. Maybe I'm wrong on this. So I think maybe I just need this. I don't know. Because I do want to revisit this, so maybe let me actually up solve. I don't know if you want to call it up solve, but I mean this will be right just because it is based off the correct answer. But I want to do it without the scene thing. I don't know that it is needed after I added all the other things. That's why I was a little bit surprised, but also that I somehow that I missed it anyway. But I don't know. Right. Okay. Well, it's not even working for here. Why is it not working for? If this is not the case, I do wonder. Like, how is it double counting? It's double counting on the 4. Why? But we already do the check. IJ. So they're the same. Oh, I see. It's because we swap both I and J and then J and I. Is it only on the 4s? I don't want permutation. I want permutation because it's easy to write and that's fine. But what I actually want is one. I kind of. That's kind of why I wrote it the other way before, is because I kind of wanted 4 choose 2 choose 2. But I didn't know how to write it that well. Maybe I could see. Because I want like, yeah. Oh, maybe I could have just written. Yeah, okay. Maybe for this one it's fine. For 4 it is fine. Just because it would have been okay if I didn't have that. I think I just missed this case, this if statement. Oh, I left in the print statement, so maybe that's why. Yeah, okay. Well, I noticed that part. Whoops. Whoopsie daisies. I thought I ran it. Oh yeah, I guess the input is not that big. Would this still be working? So that was a silly mistake that cost me a couple of times. And I actually wrote this correctly before, so I didn't even need this really. It's because I wrote it correctly, but I didn't have these 2 if statements. So what I want is then now, if I don't want this scene thing, how do I do it? So it's something like I want a partition, not even, we want a combination, and then the stuff that's not in combination, right? So then like for I, J in combinations t of 2, and then we have to get k out somehow, which is, I guess, annoying. But or maybe we could just do like t is a tuple, is a set minus set of ij, and then maybe that could have been okay. I don't know. And this is just like syntax, right? But and when we'll do this after the I guess we need this actually. List of x. I mean, you could have checked it without conversion, I suppose, but would that have worked? No. But it's a different no, so that's kind of weird, but okay. ij, Okay, so it only double checks here. So why? What is the ij kl here? Oh, because the kl is not now. No, that doesn't make sense. Huh. Let's see. Oh, because we flipped ij and then the kl. So then, so to get rid of this, we just have to get rid of that double counting. So it's not even just 4 choose 2 choose 2. It's 4 choose 2 choose 2 over. Well, it is 4 choose 2, or 4 factorial over 2 factorial factor. It is 4 choose 2. Not choose 2. Yeah, it's 4 choose 2, but then I have to divide it by 2 because we double count. Fine. So maybe you have like 4 equal to 0. So then we have 4s here. And then total, right? Maybe that is, yeah. And then now we don't need the scene thing. And that would have saved me just enough time for me to somehow finish the other one. The other one was not that bad, honestly, but I think I just kind of, I don't know. I mean, sometimes you just draw into a problem, but in LeetCode, the scoring doesn't matter anyway. Ooh, wrong answer. So maybe I do still have an issue here. Right, should be okay. We double count. The ordering, no, it should be fine. I mean, I guess we can do something like So this is where we're double counting. But why? Tell me why. One of them will appear twice. That's what I thought. So then this, okay, but it's on here. So this input has some different story to tell. That's what I thought, but and that story is hard to read. It starts here. I mean, we're off by 2, so it's impossible for me to gonna manually check. I don't know. I mean, I guess we know. I mean, I definitely. So it wouldn't have saved me that much time because I don't know how to debug this. But Yeah, I don't know. I mean, it's hard to tell where we're getting the issues from, even though we know it's here. I'm double counting somehow. Oh, I see. I could see it. I see it. I see it. I see a case. Basically, if W sub J is equal to W sub K, then we double count those. So you have to do like a scene thing, maybe, or like that's the easiest way. I suppose. Okay, fine. Maybe I just have to concede that. I don't know how to increment it, but not like you could do something like making sure that it's in order or something like that, but I think that's just like complicated, honestly. Okay, fine. Maybe I cannot do without that part. I could have done without it on the 3 part, which is kind of I don't know. Give a final submit. Alright, I mean, I guess that's the post, the retro. So maybe I could, I don't know. And I just honestly spent a lot of time on the wrong idea, because I was thinking that maybe you could do inclusion, exclusion counting, but I just couldn't get it to work. But that did prompt me to look at the math carefully to do it this way, is the idea. I don't know that I just sort. I guess sorting lets me do this, but and then after that, it just becomes a little bit brute forcey, just brute force in a smart way, which I didn't think about, honestly. I had the second operation I just kind of underestimated. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, this video, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.